All right, guys, here we go. Unit 9, Objective 5. Now we need to learn the laws of logarithm. Yes, logarithms have laws, okay? So the laws of logarithm. The laws of logarithm follows the laws of exponents, okay? So I'm gonna make a connection here with the first two laws of logarithm because it makes sense. The third one is kind of hard to see that connection, but I will try to make it. It doesn't make a whole lot of sense. It never made a lot of sense to me, but it may make sense to you, okay? So we know that when we're talking about exponents, that if I have x to the a times x to the b, it becomes x to the a plus b. So when I have a multiplication, I'm making it nice and bold. It becomes an addition when I condense. So this, I have two terms and is expanded. When I condense, it becomes an addition, okay? So it follows the same exact rule when it comes to logarithm. But when it's condensed, is a multiplication, okay? It kind of like goes backwards. When it's condensed is a multiplication. So when I expand, it becomes an addition. It's kind of like the inverse. Oh, duh. Of course it is the inverse because logarithm is the inverse of exponents, okay? But when we have a multiplication, it becomes an addition. When I have a multiplication here, it becomes an addition when I expand it. Okay, let's do the other rule. When I have x to the a divided by x to the b, it becomes x to the a minus a b. So because of subtraction, sorry, a division becomes subtraction. Same thing here. When I have a division, it becomes a subtraction when I expand it. This is the expanded version, expanded. And this is the condensed version. Why do I mean condensed? Because it's only one, okay? Condensed means I only have one logarithm. Expanded means I have two logarithms. So it's longer, it's an expanded version versus a condensed version, okay? Now, the power of power is kind of tricky because you don't see the connection at all. If I have x to the a times x to the b, it becomes x to the a times b. So it becomes a multiplication. Well, when I have log base b of x to the a, that power gets moved to the front of the logarithm. There it is. And it becomes a multiplication. Okay, so when I have a power, it becomes a multiplication. We pull that power up to the front. Okay, so see, you don't see, it's hard to see that connection here, but hopefully it made a little bit of sense. So let's take a look at a few examples right here directly next to it. Okay, so if I have log base 4 of 16 times x, it's a multiplication, is 16. We usually say 16x, but it's actually 16 times x. So in an expanded version, it becomes log base 4 of 16 plus, because it was a multiplication, it became an addition, log base 4 of x. The basis stays the same, is a 4, is a 4, it was a 4, it will stay a 4. Now, because once I expanded, I was able to evaluate, I can evaluate this part right here. 4 to what power gives us 16? The answer is 2. So see, when I expanded, I was able to actually evaluate part of it, okay? Part of it. It's kind of like if I had the square root of 9x, let's just leave it like that, 9x. Well, I can't take the x out because there's not enough, but I can take the square root of 9, which is 3 root x. So you can evaluate the square root of 9, but you cannot evaluate the square root of x, right? Same thing here. I can evaluate the log base 4 of 16, but I cannot evaluate log base 4 of x. So it has to stay there. Okay, same thing here when we have a division. I have log base 3 of x divided by 27. So I can expand it, okay, I can make it longer. Each one gets their own by doing log base 3 of x minus, because it was a division, log base 3 of 27. Now, because I can partially evaluate this, I can say 3 to the third power gives me 27. So I can evaluate part of my expansion and leave the other one alone. Okay. All right. Here I have log base 5 of 25 to the x power. Why don't we bring this x power to the front? Because that's the law of logarithm. Okay. I brought the x power to the front and it becomes x times log base 5 of 25. We can certainly evaluate this right here. 5 to a power gives us 25. That's a 2. And since we don't never say x2, we say 2x. We just put the variable, sorry, the coefficient in the front, okay? And the variable in the back. So those are the laws of logarithms. Let's see if we can use them, all right? I'm gonna do one of two of these and I'll let you do the others, okay? Because we wanna go into other problems. So take a look at over here. Let's check to see if you understand it. Log base 6 of 36 times x. So this is the condensed version. This is the expanded version. So it's going to become log base 6 of 36 plus log base 6 of x. Now that I expanded, now I can evaluate log base 6 of 36, which is 2 plus, but I cannot evaluate log base 6 of x because I don't know what x is, okay? So I want you to try this other one right here. I'm going to label number 2. Okay, do you understand the basics? I'm going to do this other one over here with the power, and then I'll let you do the other one. So because I have this power up in the front, I'm sorry, up here, log base 4 of x squared, I'm going to bring this power to the front. It's going to become 2 times log base 4 of x. And that's it. I can't take it any further. That's it. Okay. So sometimes we can evaluate and sometimes we cannot. And that's totally okay with it. Okay. So I want you, I'm going to put a W for you and a W for you to do those two right there. Not a W, but Y. Sorry. Thinking in another language here. Okay. So I'm going to do a few of these 1 through 6. I'll select a few to do it for you. I will be nice and I'll select the ones that are more challenging. Okay. I'll let you do number 1. I'll go ahead and do number 2. Then I'll do number 3. And then I'm going to put that U. Okay. And I will do this one. And then I will do number 3. And then I will do number 5. And then you do number 4. And then I'll let you do number 6. Okay. So I selected 3 for you to do, and I'll do the other ones. Okay. So let's go ahead and do number 3 first. Here we go. Log base 2. I have 3 items and I'm gonna put check mark on them. I have a 3, I have an x to the 5th, and I have a y. As you can see, 3 check marks, 3 values. Because I have 3 values and they are multiplying each other. It is 3 times x to the 5th times y. Their multiplication. I'm going to expand it into addition. It's going to become log base 4, base 2. Log base 2 of 3 plus log base 2 of x to the 5th plus log base 2 of y. If you stop here, you're not going to get full credit because you need to check for all 3 laws of logarithm. And if I pay attention closely, I have an exponent right here. So I can still pull that up to the front of this single logarithm, not to the front of everything else. And this is going to become log base 2 of 3 plus that exponent that's coming to the front, 5 times log base 2 of x plus log base 2 of y. There we go. Now I have no exponents and everything has the same, all the logarithms has the same base and everything has its own logarithm. That would be your final answer. I can't evaluate any of this Okay, I cannot take log base 2 of 3, so I leave it alone. All right, let's go to number 2. I have log base 6 of the square root of 6 and the x squared. I have 2 items, so I'm going to have 2 logarithms. It's going to be log base 6 of the square root of 6 plus, because it's a multiplication here, okay, I have the square root of 6 times x squared plus log base 6 of x squared. Now, you can rewrite it if you don't see it. You can rewrite that square root of 6 as 6 to the 1/2. Okay, so that's the same exact thing. The square root is the same as 1/2 power. So I can rewrite this as log base 6 of 6 to the 1/2 power plus log base 6 of x squared. Now notice, I'm going to use the highlighter here. I have the 1/2 power and the square. So I got to pull those powers, those exponents to the front. So let me erase this extra work right here so I have room. So I'm going to pull those exponents. Let me take blue. I'm going to pull this exponent to the front of this one and this 2 to the front of this one. Okay, so they have to go to the front of each of the logarithm. So it's going to become 1/2 times log base 6 of 6 plus 2 times log base 6 of x. Now look at this right here. We can evaluate this, right? 6 to what power gives us 6? 6 to what power gives us 6? Well, that has to be a 1, right? It's the first power. So this becomes 1/2 times 1 plus 2 times log base 6 of x. Well, 1 times 1/2 is just 1/2. 1/2 plus 2 log base 6 of x. I cannot go any further. That's it. Okay, so I have 1/2 plus 2 times log base 6 of x. Okay, so I'm going to let you try number 4, number 1. I'll do one more, which is number 5. We have a division, which tells us that there will be a subtraction. Okay, so let's go ahead and take care. I have the numerator is going to be separated by the away from the denominator. So we're going to have log base 7 of 49 minus, because that's the division, log base 7 of 2x. Now, before I evaluate this first logarithm, I see that I still have a multiplication. I have a 2x, a multiplication. So I'm going to go ahead and expand it one more time. Log base 7 of 49 minus log base 7 of 2 plus log base 7 of x. I splitted this 2x. Let me go ahead and highlight it. I splitted that 2x into that addition right there. Okay, now can I evaluate any of this? Well, I cannot evaluate the third one or the second one, but I can evaluate the first one. 7 to what power gives us 49? That's 2. 7 squared is 49. Minus log base 7 of 2. I cannot evaluate that. Plus log base 7 of x. Okay. All right. So I showed you exponents a couple of times, how to pull it to the front, how to evaluate. You should be able to do question 4 and 6, 1, 4, and 6. Okay. All right. Can we work backwards? If I give it to you expanded, can you go ahead and condense it? Can you work backwards? I want you to put something in your head. We read books, we read English, we read math from left to right, just like we do domain is from left to right, okay? Just like we read a sentence from left, do you understand the basics? From left to right. We're gonna do the same thing with logarithms, the same thing with mathematics. We read it from left to right. So let's see if we can condense from left to right. I'm going to start from here, okay? And I'm going to move that way. I have log base 6, log base 6. I have 2 of them. I'm going to condense it into a 1 log base 6. I have a 10 plus, I have sorry, I'm saying this wrong. I have log base 6 of 10 plus log base 6 of x. And because I have an addition, this is going to become 10x, a multiplication. So I condense it down to 1. Okay, see if you can do the subtraction. What is it going to become? Okay, let's do the other one. I have 3 times the ln of x. 3 times the ln of x. Well, that 3 needs to be brought up here because that's an exponent. So it becomes the ln of x cubed, right? I want you to try this one. I have log base 2 of 3 plus log base 2 of x plus log base 2 of y. You have 3 additions, 3 terms, a 3, an x, and a y. You should be able to condense it to 1, okay? Let's go ahead and do some challenging ones. I'm going to do a few, and I'm going to leave a few for you to do. I want you to challenge yourself and condense as many as possible. So as a matter of fact, if you want to go ahead and pause it and condense as many as you can, that would be great. Okay, so here we go. I'm going to go ahead and do number 1. Log base 4 of 8 and log base 4 of 2. So I'm going to condense it into 1. I have an addition. Is going to become log base 4, the base don't change, 2 times 8, 2 times 8, which is log base 4 of 16. Now I can evaluate this right here. It's not always possible, but sometimes it is. 4 to what power gives us 16? The answer is 2. Happy? 4 squared gives us 16. Right after I condensed, I was able to get the answer. All right. Number 2, don't be scared of ln's. ln of x minus ln of 3. I have subtraction, so it's going to become a division. We go from left to right. So this is going to become ln of x over a 3. And that's it. If you want to put little parentheses, that's fine. Is the ln of x over divided by 3. Okay. All right, this one has a power. I'm going to let you do it. I'm going to do another one that's a little harder for you, which will be number 4. Okay, here's my power of 3. I'm going to put it back over here. Here's my power of 1/2. I'm going to put it back over here. So this is going to become log base invisible 10 of x cubed plus log base invisible 10 of y to the 1/2 power. Well, 1/2 power can be written as square root. Remember, x to the 1/2 is the same as square root of x. So I can do the same thing. Log base invisible 10 of x cubed plus log base invisible 10 of the square root of y. Now I'm done putting all the powers back to where it belongs. Now I can condense into one single logarithm. Is log base 10, as it is invisible, of x cubed times square root of y. Okay, so there we go. We condensed it. Okay, I would like for you to try number 3. That's you. Number 5. That's also you. I'll get you started with number 6. That's going to be me and you. Me and you. Okay. All right. I'm going to put the 4 back in here. I'm going to put the 3 back in here. And I'm going to put the 2 back where it belongs. So it becomes log base 4 of 2 to the 4th power plus log base 4 of x cubed plus log base 4 of y squared. So they're all put back where they belong. I'm going to take one more step. Log base 4. Well, 2 to the 4th is 2 times 2 times 2 times 2, which is 16, plus log base 4 of x cubed plus log base 4 of y squared. Now I'm going to let you decide, and that's my trick for today. Not a trick, but my challenge for today. Am I going to evaluate this guy and then condense, or do I condense it all at once? Okay, I want you to decide that. I want you to think. Think. I want you to think, should I evaluate and get a number plus the condensed form? Or should I just condense it all into one single logarithm? Okay, I want you to decide between these two questions. Between these two options, which one should you do? And then I would love to discuss that in class and show you what happens and are they equivalent? Perhaps they mean the same thing. Let's find out in class, okay? So that's it. That is laws of logarithm. We're going to do lots of practice in class. Good luck.